I'd plug in pi over 2 to find the limits first. I'm going to write cosine of pi over 2. That's inside of cosine, but don't forget there's a squared. Now, I like putting the squared on the outside of it. That way I remember that I do the squared after I do the cosine part. And on the bottom, I have 1 minus sine of pi over 2. All right, so let's see what we get. What is cosine of pi over 2? That's just a 1, right? Is it? No, that's 0. This is 0. 0 squared is 0. And on the bottom, I have sine of pi over 2 is 1. So I have 1 minus 1 is 0. Okay, so we got indeterminate form. It checks out. That means we can use L'Hopital's rule. And so I'm going to take the derivative of the top and take the derivative of the bottom, then find the limit. So when I take the derivative of the top, remember it's cosine x squared. Okay, so that means we're going to have to use a chain rule there. On the bottom, we have 1 minus sine x. Now it's kind of nice that we just have an x inside of cosine, because if we had anything else inside of cosine, we'd have to do the chain rule twice. But we don't have to, so don't worry about it. So let's do the top first. We would have 2 cosine x, and we take this and we would multiply it by the derivative of the inside. The inside is cosine x. What's the derivative of that? Negative sine x. Oh yeah, now I know why we're doing this one, because this one you're going to have to simplify after you take the derivative. So derivative of 1 is 0, so that's gone. And then I take the derivative of negative sine. That would be negative cosine. Because the negative was already there. It's not like I got a negative when I took the derivative. Okay, all right, can I cancel anything out here? Can I cancel these out? Yes. Now, why? How come I'm allowed to here? I'm allowed to cross those out.
Because they're multiplication.
Because on the top, they're multiplying. If on the top they were adding, you cannot cancel those out. But since they're multiplying, I can cancel out that cosine. I can actually also cancel out these negatives, the negative 1. And so what am I left with? I'm left with 2 sine x. What is the limit as x approaches pi over 2 for this? It equals 2. You just have to plug in pi over 2. Okay, questions? I have some questions about this. How come you're allowed to cross these out? Because some of you guys got something wrong because you crossed something out. Like if I had cosine x plus, or let's say minus, we'll make it look similar, minus sine of x, and I had it divided by cosine x, I cannot cross out these cosine x's. That's not allowed. If you could factor out a cosine x, then you could cancel out the cosine x's. In this case, in our case, what we have is 2 cosine x multiplying to negative sine x. So actually, I have a negative 2 cosine x sine x. Look at cosine x and sine x like they're 2 variables. On the bottom, I have a cosine x. Actually, it's a negative cosine x, but a negative divided by negative is a positive. So now I have cosine x and cosine x. Look at those like they're variables. That's why you're allowed to cross these out, because there's no adding and subtracting on top. You're allowed to cross them out. They're all multiplying. Does that make sense? Kind of, maybe, sort of. Do you understand how I got negative 2 cosine x sine x? Okay. So look at this. 2 mn over negative m. Do you know how to simplify that? Okay, you know these would be positive, right? And you would cross out these m's, right?
Yeah.
That's the same thing. Except our m's are cosine x, and our n is sine x. Does that make sense?
Yeah.
So we got algebra going on here.